Okay, so we are told to find the curvature of RT at 0.100 for question 6. So we know that to find the curvature, we have the formula KT equals the magnitude of R prime of T cross product R double prime of T over the magnitude of R prime of T to the third power. We know that we can use ln of t or any of the other two components there and set it equal to 0 in this case to find the value of t. So we can both sides to get rid of ln. So we get t equals 1. So then we can find r prime of t, which is 2t. The derivative of ln of t is 1 over t. And then we have a product rule. So we know that the derivative of t is 1, and then times ln of t, plus the derivative of ln of t, which is 1 over t, times t, which can be simplified to 2t, 1 over t, and ln of t plus 1 since the two t's cancel out. Therefore, we can find the magnitude of r prime of t at t equals 1. So we can find r prime of t at 1, which gives us the square root of 2 times 1 squared plus 1 over 1 squared plus ln of 1 plus 1 squared. So ln of 1 is 0, so that goes away. So we are left with the square root of 2 squared, which is 4, plus 1 squared, which is 1, plus 1 squared, which is 1. So we have the square root of 6. We can raise this to the third power. So r1 or r prime of 1 to the third power equals the square root of 6 to the third power, which is 6 square root of 6. So then we can find r double prime of t, which equals 2. 1 over t can be used as t to the negative 1. So the derivative is negative 1t. Negative 1 minus 1 is negative 2. And then we have the derivative of ln of t, which is 1 over t. And then 1 is 0. So we have 1 over t. Then we can do the cross product of r prime of t and r double prime of t. So we have 2t 1 over t ln of t plus 1, and then we have 2 negative t to the negative 2, and then we have 1 over t. So then we have the component of I, which is 1 over t times 1 over t minus ln of t plus 1 times negative t to the negative 2 power. Then we have negative j, which is 2t times 1 over t minus ln of t plus 1 times 2, and we have k, which is 2t times negative t to the negative 2 minus 1 over t times 2, which gives us 1 over t squared ln of t plus 2 ln of t and negative 4 over t. So then taking the magnitude at t equals 1, of the cross product, we have 1 over 1 squared ln of 1 plus 2. Again, this is 0, so that cancels out, leaving just the 2, plus 2 ln of 1 squared plus negative 4 over 1 squared. This is 0, so we have 2 squared, which is 4, negative 4 squared is positive 16, so plus 16 gives us the square root of 20. So plugging in the values to the curvature formula, we have kt equals the square root of 20 over 6 square root of 6, which can be simplified to square root of 10 over 6 square root of 3. So that gives us the curvature of RT.